Hello everyone, welcome to Canal Physics. Today we are looking at measurement and prefixes. So as we discussed in the previous video, there are several quantities that we will encounter in physics, and these quantities, either fundamental or derived, have different units of measurement or simply just units for short. So with the example of distance, there are several units we could use for distance, but the appropriate unit of distance will depend on the measurement we're actually making. So for the size of an ant, millimeters would typically be the best or the most appropriate unit to measure the size of an ant, unless it's a really big ant, but we'll go with the usual ants. Length of a shoe, centimeters is a reasonable unit of distance. The width of a room, so kitchen, bedroom, bathroom, typically meters. Lowercase m for that to symbolize meters. And the flight from Perth to Singapore. It's a fairly large distance relative to what's listed above. So kilometers would be the most appropriate, or km. Now, something to take note of is that 3 of these units have a prefix, and these are milli, centi, and kilo. So what actually are these prefixes? Well, put simply, they are numbers, but more specifically, they are numbers that get multiplied by the unit, or unit of measurement, and in this case, that is the meter. So for milli is simply 0.001, but in index form, that can be written as 10 to the negative 3. For centi, C is 0.01 or 10 to the negative 2 meters. That doesn't have a prefix, so we're going to skip that one. And kilo, lowercase k, is 1000. And that can be written as 10 to the power of 3. Following on from this, we see a more complete list of prefixes in this table. Now, by all means, these are not all of them, but these are the ones you will commonly use throughout your physics experience. So we see here we've got in this column the name of the prefix. And in this column we've got the symbol for the prefix. Here we have the factor, which is that number we multiply the units by in standard form or in just written as a normal number. But over here we've got a more elegant way to express the number in index form. So how do we actually use prefixes? So it's first good to know that prefixes are usually provided to you in a table in assessments, either in a test or an exam. So you don't have to memorize these prefixes, but you do need to know how to use them. So here I've got 3 examples. We're just going to convert those into meters, and we need our prefix table to do that. So let's start with 30 centimeters. So we see that to rewrite 30 centimeters in meters, now this is probably something you can just do off the top of your head because you've got experience with rulers, and you'll probably see that, yes, I know that there are 100 centimeters in a meter, but what I want to do here is just practice using the prefix table. So even though you might be able to do these off the top of your head, we need to know how to use the prefix table, especially for more complicated examples. But we do start simple here. So to rewrite 30 centimeters in meters, all I need to do is see that the prefix here is lowercase c or centi. So that is here in my prefix table, and that corresponds to a factor of 10 to the negative 2. So all I need to do is rewrite the number. I don't even need to change the number. so 30. But instead of writing centi, C, I write times 10 to the negative 2. So it's as simple as that. You're literally just copying the table, but you must always multiply by that factor. And putting this in my calculator, I get 0.3 meters. Sorry, I don't want to be incomplete there. Right, meters there as well. Let's do the next example, 1.45 kilometers. Again, you might be able to do this just off the top of your head from common experience, but we're trying to use this prefix table. So K or kilo here in the table is my prefix of interest, and the multiplying factor is 10 to the power of 3 or 1,000. So again, I just rewrite the number, don't have to think here, but instead of writing K, I write the corresponding factor, which is times 10 to the 3 meters. And in my calculator, this gives me 1,450 meters. Last example, 0.07 millimeters. Again, this little m here is representing milli, which is a multiply factor of 10 to the negative 3. So rewrite the number, 0.07, but instead of milli, I'm going to write multiply 10 to the negative 3, the corresponding factor. But I've still got my meters there, the second m, which is here. Still got to write that. That's my unit. So I can't get rid of that. And putting this in my calculator, I get 0.00007 meters. Moving on to slightly more complex examples, I'll start by reading the first bullet point. When an operation is performed on a unit, the same operation is applied to the prefix. So to understand what this means, I'll start with a very common misconception. So it is correct to say that 1 meter is equal to 100 centimeters. So nothing wrong with that, that is correct. But an incorrect extension of this would be to say that 1 square meter is equal to 100 square centimeters. So unfortunately that is incorrect. So we're dealing with area here, but the same idea will apply to volume as well. So looking at the example of comparing length, area, and volume, these three boxes here, the easy one to understand is that centimeters to meters divide 100, because that's those prefixes we were looking at. So this divide 100, this is the same as saying times or multiply 10 to the power of negative 2, just like with the prefix table and the examples we did previously. But with area, you're now going to square these units. So the first bullet point suggests that we must also square the prefix. See, if you're going from centimeters, square centimeters to square meters, you divide by not 100, like with length, but divide by 100 squared. And if you're going the other way, to go from square meters to square centimeters, you multiply 100 squared. And the same idea goes for volume, except it's cubed. Both are cubed, the unit and the prefix. Now looking at these examples I have here, A, B, C, D, we will convert the following. 7 square kilometers, we're going to convert that to square meters. So it's very similar to what we did before, but one extra step. So again, we just write the number 7, we don't have to think there. But now we've got this kilometer here, and it's going to be squared. We have to multiply by 10 to the power of 3, because that is the metric multiplier or factor for kilo, but it's also going to be squared. And we've still got the square meters here, so we still have to write that. We've just gotten rid of the kilo squared. And from indice laws, if we raise a power to a power, we multiply those powers. So the answer would be 7 times 10 to the power of 6 because 3 times 2, 6 square meters. And in our calculators, that gives us 7 million square meters. Moving on to question B. So one thing to take note of is that this is going to be a volume conversion, so the power is 3 or cubed. So we're going to just write 1 centimeter cubed, so centimeters, that is times 10 to the negative 2, 1/100th of, but it's also going to be cubed. Okay, don't forget that first bullet point on this page. And then we, don't forget to have complete working every line. That is, the cubic meters is left now. We've gotten rid of the centi cubed. Simplifying this, we get 1 times 10 to the negative 6, because negative 2 times 3 is negative 6. And that's cubic meters. And in your calculators, in standard form, this gives us 0.000001 cubic meter. So with examples C and D, these are going to be slightly different to A and B, because in A and B, what we were doing really was going from prefix or units with prefixes to a unit with no prefix. So we got rid of the kilo squared in A and the centi cubed in part B. But for C and D, you can see we're introducing a prefix when we're converting. So to put it simply, we're going to do the opposite of what we've done before, which is instead of multiply a factor, we're going to divide the factor. And this will reintroduce or introduce the prefix. That being said, let's solve question C. So as usual, we write the number. Sorry, a bit messy there. But this time we divide the factor for the prefix, which is 10 to the negative 3, because we're trying to convert to milli. And we also must square it, because it is square millimeters. Simplifying gives 0.039 over 10 to the negative 6. And in our calculators, we get 39000 square millimeters. Now part D. Again, just take note that we're going to centimeters. We're trying to introduce the centimeter prefix, so we're going to divide instead of multiply. And it's being cubed. So this will be 0.0001 divided by 10 to the negative 2, being the factor for centi, and we cube it. And simplifying 0.001 over 10 to the negative 6, and this will equal 100 cubic centimeters. And that's it. Thank you for watching this video. If you found it helpful, please like and share it, and subscribe to my channel for more.